Into the holy war of modeling notations. Actually, that is us. I'm the left one, without a fat suit on, and him without gray hair. Actually, to be honest, it's not a picture from yesterday. Those pictures, yeah.
Really?
Really.
Damn it!
The pictures are 8 years old, at least 8 years. And it remembers me that I'm working with that guy for more than 8 years together and still doing things together. Okay, this time the holy war of modeling notations. And that was not the right button. Okay, modeling has evolved over the years, and we started in the early years. People thought that they wouldn't like to be on a more abstract level because they don't want to code that boilerplate code. And so they started to group together and formulate standards, dark standards. The dark years was UML. I mean, we had the OMG, and the OMG formulated very, very huge papers of specifications with 2,000 meta classes for boxes and lines. But then we came to the shiny years. I mean, the modeling community in Eclipse is very huge, as we can see here. So in Eclipse, we have done a lot around modeling. And in this session, it's not really a war. In this session, we would like to guide you through the early things that we have done in Eclipse to things for the future. And we have so many sessions here at Eclipse still about modeling. And so let's start with the base for everything. It's the @merx framework. Not really. It's the @merx framework, EMF, the base of nearly everything that we have in the Eclipse universe for modeling. And there are these fancy tree structure editors that you can use to instantiate EMF models. Okay, nobody want to deal with that. So we have other technologies upon that. And of course, we want to care about graphical and textual modeling, because we have seen that graphical, as we learned from UML, is not the only truth. Textual is cool as well. So what do we have? We have GMF. Who does not know what GMF is? It's quite old, so everybody knows that. It's an abstraction over GEF. GEF, Graphical Editing Framework. That is an abstraction over Draw2D. So we have abstractions over abstractions, and we had that fancy way of defining those very nice looking editors.
It's beautiful by default, right?
Yeah. I mean, it's ready to go. Then there came Graffiti along from SAP. They said, oh, we don't want to work with those ugly models. So they started to create something that looks good out of the box. It's based on GEF, GEF3. Very old technology. It looks very good, but still nowadays nobody's using that anymore. Then we have Sirius. Sirius is very popular because it looks good. You can do crazy things with that, but it's still an abstraction over an abstraction because Sirius is based on GMF. So it's based on a technology that is nearly dead. That's not cool. And then there is Xtext. Xtext, who does not know what Xtext is? Okay, textual modeling, I don't have to say much about that. It's pretty cool to do that, but it's not the only thing. Who is modeling?
Yeah, and here I'm kind of celebrating my prejudices. So when I think about modeling, then I'm basically thinking about architects and developers. So I will move here. Architects, hey, how are you doing? Architects and developers. So these are the two kind of groups that I picture when I think about modeling in our ecosystem. And those have different requirements and different ideas about what a model actually is and how it's supposed to be used and how the information is supposed to be modified and edited. So when I think about architects, I'm thinking about diagrams, boxes and lines, drawing layers above layers and to capture the interactions that you introduce. And when I think about models that developers care about, then I'm actually thinking about code, which is nothing else than a model because it captures information from the real world in a more abstract fashion. So it boils down to the question, do we have graphical modeling or textual modeling? And here we have this, like this thing, is it a versus or is it not? Is this a war or is it no war? And apparently it's not a war, even though there may be differences here. So the advantages of graphical modeling, they are kind of apparent. You can use a notation that matches the real world, kind of. So when you model how a car is supposed to be assembled, then you can use components that really look like the stuff that you have. You can use icons and nice visualization. So it's something that you closely resemble to what you know from your otherwise not software related daily work. That is an advantage here. You can define syntaxes where the location of elements may even impose semantics. So when you say I draw this layer above the other one in my fancy UML-like model, then you could also derive constraints from that. So that would be an advantage of graphical notations. And even though you may not be super familiar with the concrete meaning of each and every UML element, as Holger already mentioned, there are like 2,000 something of those. Even though you may not know every nifty detail, when you look at a class diagram or a sequence diagram, you can like get the gist of it, and it's easy to reason about most graphical notations. That's what I claim. And graphical notation is pretty useful when it comes to modeling structures. That's why the claim that it's well suited for architects. Textual modeling is a little bit different though. So here we have mostly users that come from the like coders mindset. So it's more about writing source code rather than modeling things, even though the actual activity is more or less isomorphic. So it's pretty much the same whether you do modeling or coding. Anyway, the user group for textual models is mostly like by heart developers. These are also the users that care about existing workflows, existing tool chains. So they have git diff merge workflows. There's the intrinsic motivation to know what was changed by my colleague in every detail. So they want to compare files. And that's often easier with existing tools based on text rather than homegrown tools based on graphical notation. That's what I mentioned here. And in the end, textual models are often well suited to implement or to implement actually, to model algorithms and logic. So coming back to this one, it begs the question, is it really just two groups or is there an overlap? And of course there's an overlap, otherwise this entire thing would be meaningless, doing architecture and developer work. So there is a sweet spot where we basically want to combine graphical and textual notation. And what would this be? What is the user group here? That is something that is also related to the question. So what is the usage metaphor that we have here? So when we think about graphical editing, we often have like clicky gestures or editing gestures that do work on some abstract syntax. So it's oftentimes not the concrete syntax that you modify. You don't take a pen and draw it like in MS Paint, but you create a class or a method, and that one would be represented in the concrete syntax afterwards. So the flow is via abstract syntax to concrete syntax, and then you get the visualization. With textual modeling, it's often different. So usually you modify the concrete syntax until the parser recognizes the text again, and then it will produce the abstract syntax from that. And it also could work the other way around, but this is also a dotted line here. It's not so common. Usually you have the other way around only when you perform refactorings, for example. How to combine those?
Yeah, there were many attempts. I mean, GMF combined with Xtext, we have seen a lot of examples, but still nothing really works well. Then we have the same approach with graffiti. Someone tried to do that. We had talks about that, but still the very same problem. We had serious. I mean, that worked better because it was more or less a co-work of people that are very familiar with Xtext and the guys from Sirius, and that worked out, but still they had a lot of quirks, and we had several sessions about that, what the quirks are. Still problems. And then of course, as all the frameworks I've mentioned are built on GEF, someone tried to combine GEF and Xtext. I mean, same story, same problem. We have, on all attempts that we have so far, we have nothing that really works out perfectly. I mean, in the theater, during we are talking here, there is a session about combining textual and graphical models, and I'm pretty sure that they will talk about quirks. Okay, where's the problem?
The problem is exactly what you mentioned. So we have an impedance mismatch between those two habits, or those two mechanisms of working with the models. So the impedance mismatch, as I already pointed out, is that you either edit the abstract syntax or the concrete syntax, and then in either case you get some like quirks, difficulties, things that you have to work around, you have to adjust your habits, and still we wonder what is the actual. Somehow confusing my slides today. Awesome. So what was the conclusion was from that we do not necessarily want to edit both syntaxes, but maybe just have a visualization of one of the two. So the primary editing artifact becoming oftentimes the textual language, and then we get graphical visualization for the very same information, oftentimes instantly updated. So here we have an example where this is just a viewer that allows to do some drill down, some exploration, but if you actually want to modify the model, there's no way to just draw a new line here, you would have to go into the text. That was usually the workaround for this attempt. And eventually I have this additional bubble here. So, but what is with this entire space here where we are talking about people that are not necessarily developers, that don't want to be developers, people that are not considered to be architects, people that are not from the IT business. So business experts that want to model their Fachlichkeit. So the core, what makes up their business. I practice that word very hard in English. So business experts, they don't want to do, they usually don't want to be programmers, they don't want to be modelers, they don't want to They just want to work with the tools that they know and that they are familiar with, and this is usually, I would say, so the de facto standard is still some tool stack from a big company, and then we have Word and Excel, of course, those things. And why is that the case? So why do these people work with these tools? Because they are free. What they want to, they can freely combine different aspects, different notations. Especially in Word, you can embed images and so on and so forth. You can draw fancy diagrams in PowerPoint. You don't need any UML tool to visualize boxes and lines. And the most prominent example here being Microsoft Excel, which is a programming environment, I would say. So you write complex formulas, you work with tables, that is nothing else, in matrices, etc., etc. So in the end, these business experts, they do modeling all the time in an informal way, and the question is, why are they still working with these tools rather than more formal languages? And the answer to that is the freedom that they get. So I already mentioned they can freely mix different notations, different aspects, and this is more like a social aspect. If it's informal, they are allowed to make mistakes without anyone being able to prove them right or wrong, which is good and bad at the same time. But that is something that we can discuss now. So what is the implication here?
Yeah, there are already tools out there that can handle that problem. Let me get an example. So this is more or less natural language, but still it's formal enough. At the end, in the back, there is an AST, and there's one technique out there that can have more or less templates for prosa, so that you can say, this is the function that I want to call. In the middle, there's the decision table that you normally have as switch case things in your code. But why not only drawing that? I mean, the same information is there, and it's more readable. And for the natural language, for a textual attempt like we do with Xtext, that would be impossible, because there are white spaces in between, and yeah, a parser cannot deal with that very well. And as you can see at the end, there is already the result that is shown. I mean, we have something like that in Xtext nowadays, that's code mining, but in this attempt, it's pretty cool that you have some kind of templates there. This is the parameter, you can see that here. Same story here, you can see that here at the end there is the result. That's pretty cool. I mean, we can do things like mixing text and graphical notations without having problems in synchronizing, because we are dealing with the same AST, we just represent it in a different way. So, as you might guess, these are not normal graphical editors, and they are not normal textual editors. At the end, this is more or less a picture that has been drawn, and you interact with your keyboard and the mouse, and because of the position where you do something, that thing that you did, the event, will be recalculated in the back to model transformation, and then the representation will change. That's completely different than textual editors work. So we can do other things like mathematic things. I was in a project where we had insurance mathematics that normally have Word documents where they write down pseudocode, and they claim that is not programming. Okay, then someone else has to write C code out of that. We will come to a more specific example of that. But what I want to say is they don't want to write for loops. They would like to have sigma signs, and with such way you can have complete support for math. I mean, we can drive it further. So here we have vectors, and we have special signs that are normally not possible in textual editors. And yeah, that's cool about the way projectional editors work. And decision tables, I already said that, and even more complex examples of decision tables are possible. And the cool thing about that is, in the way this tool is doing it, you can have different representations for the very same concept, and depending on the guy who's sitting in front of the computer and looking at the model, he can decide how things should look like. And maybe he's not interested in the details of some parts, but he's more interested to see the overall thing. But it's still the same AST. So decision trees for non-programmers, they are used to think about that in such decision trees, but in the way we normally model, they can't express that. So this tool gives freedom for them. And as we talked, they normally do Excel, so they are used to have tables and all that. This is one example, this is another one. This is actually for truck drivers, for planning how long they can drive and when should they start, in the middle of the night or in the day. That was a customer project where they did that in Excel. But the problem is Excel is not really formal, and they just want to analyze that. This is the example that I talked about when we came to that mathematics science. I mean, that is insurance mathematics. And what they did is, instead of writing Word documents and sending that to India, they just can write it in the very same way, press a button, and they end up in C code. And they can directly test, and so the turnaround is very much faster than before. And you might have guessed, projectional editors are done nowadays with MPS. And MPS is not Eclipse, to be honest. But
it's a German tooling team who did that.
Yeah, cool. Yeah, but still, MPS is not as cool as you might think, because it's still a fat client. On a fat client, nobody wants a fat client. I mean, if you, as a business user, you don't want to install something. So what do you want to do? I want to click on a link. Something should open that I understand. Then of course, it should be fast. It should look nice, not these ugly editors. No, I don't want to install something. I have a browser, that should be enough. Did you get it? Okay, the future is webby. So we have several talks around several technologies. And from this point on, I would like to introduce you to the technologies that we have so far and where we want to go. So what do we have so far? EclipseCon. Who does not know what EclipseCon is? Okay, in EclipseCon, you can program in the browser. That's pretty cool. Nowadays, you can combine that with textual languages with the LSP protocol. That's pretty cool. Then we have Thea, of course. That's breaking through. I mean, we have nearly full IDE in the browser. It's pretty cool, but still, it's just text. And of course, this is how it looks like. We have Git support and all that. I mean, that works for programmers. That doesn't work for business experts. Not saying that this doesn't work. I mean, the audience who's dealing with that is a different one. Yeah, Thea has textual support and Sprotty. That is another thing that you might have heard about these days at the conference, is for having graphical representations, but only viewers. So it's not an editor. Then the serious guys came along and said, Sprotty looks nice, Thea looks nice. We know how to deal with graphical editors. Why not creating a graphical editor with those technologies? I mean, that's Sprotty with Thea in the serious way. It's a very early state of that, but still, you know, everybody is going to the web. Wouldn't it be cool to have projectional editors in the web? I mean, hopefully you share my idea that projectional editors could be the way of solving our problems. What else there? Currently we are working on a team. Would you like to join me?
Yeah.
We are working on a team together at itemis to drive a new project named Convecton. To be honest, this is not open source.
True. And Convecton aims at solving the problems that we outlined so far. So the current approaches often address the needs of developers. Usually have, to put it simply, you move your workspace from your local box to someone other's machine into the cloud, and you access it via a browser, but still it's your workspace specific to you. You have your instance there. Okay, you address many of the problems. There's almost no deployment overhead anymore. You don't need to install any updates. You just follow links. You can, I don't know, review code on GitHub by clicking on a link and you get a working workspace, etc., etc. But does this really address the needs of business experts that want to work collaboratively on their models, on their instances? I would say this is still a far way to go. With Convecton, we have a different approach to web-based editing, web-based modeling, web-based programming, because we consider the multi-user and the collaboration aspect more important than it's usually done with the other stuff that we saw so far. So how does it look like in practice? This is a super fancy default Spring login page because I'm personally a great UI designer. So let's log into Convecton as Nat, and this is what you would get. What we see here is blurry, but still, so you may have an idea that this is a Java-like notation for a class called math and a second class with the name class A. And the very same information is visualized twice here to make it apparent that we are working on a shared model by using a TypeScript-like notation for the same objects. So in TypeScript we do have namespaces, in Java we have packages, but still in TypeScript we could have classes, and here is a class math with a plus method similar to the plus method above, but not similar, identical to the plus method above, but simply a different notation. And here's a third visualization of this one where we just have the outline. So what happens if we start editing here? As you can see, as soon as I start editing above, the content below is updated immediately because it shares the underlying model. So there's no two instances of class A, but only a single one, and the representation is updated. So what you edit is the abstract syntax projected as a text syntax, and this actually works pretty well. So what can we do now? Multi-user is something that I claimed is supported here, so let's log in as Maggie into the system. And as you will see here, we immediately indicate that there's now a second user, similar to what you may know from Google Docs. So now we have Maggie and Nat both logged in, and as soon as Maggie starts clicking and weirdly moving the mouse, you see that Nat gets instant feedback on his side that Maggie is now working on this or that instance. So Collaboration is working very comparatively to what people are used to from Google Spreadsheets, Google Docs, Google presentations. So whenever some interaction begins, you get feedback in the other clients so that you know maybe I shouldn't touch the very same piece of the model. What happens when Maggie starts editing? It did already happen. As soon as Maggie started editing, we also update. So you see the changes, not only the selection. And in practice, this is like live synchronized, and you see also immediately when the change happens and where and who did the change. So we get into a stage where we are no longer working on an isolated workspace that is pushed to some Git repo where another user is checking out, because all these metaphors are alien to business experts. They want to have a live and shared model. And this is something that we really sport with the Convecton infrastructure behind under the scenes, that we have a model repository that's the same for all users, including access control, etc., what you would expect. So the idea of Convecton is to bring the advantages of projectional editing and the advantages of the web. Actually, not only the zero deployment effort, but the advantage of being able to work collaboratively on the same information and the same data to business experts, so that they can model their Fachlichkeit and that they can capture the business and move forward with a faster pace than it would be possible with documents that are sent to India to be copy-coded by people that don't even have a clue what they're doing there. So much about the approach to like different modeling notations. So there's no yes or no graphical textual is better, because you want to combine everything, but it has to work in a seamless way. Do you have any questions on this?
Yes.
Do we have time for questions? Yes.
Yeah, okay, so
That's good.
regarding your Sirius plus XX experience, it used to work at least 2 years around here, so you don't get any problem there. And you are right that you recognize it's a problem, because when people are trying to edit non-source representation, there will be problems. We are trying to edit derived representation. What you did is very interesting. It reminds me of the Jeff content, right? And also cut of my Yaf, but put in the web. So I didn't get what really the new approach you bring outside that really cool combined representation. The combined representation is really cool, right? The in-place editing is actually may bring you to the same problem, because the Sirius also consumes the changes in the EMAP semantic model, right? And produce a representation. So you're doing the same way.
Yeah, no.
You're just, you just found the better semantic source model for your representation. That's it.
Yeah, but Sirius doesn't have a projection for text.
Protection?
A projection. You say Sirius is a projectional editor, true, but it doesn't have a projection for text. So it's just a graphical projectional editor.
You may contribute any representation to Sirius.
So let me try to repeat the question so that I'm sure that I understood it correctly, and that's also on record. So what you mentioned is that the approach is not so much different from the Sirius approach, because it's actually also editing the AST. And I'm with Holger here. So what the projectional editors allow is an appearance that's very close and very similar to a text representation, which you would usually not get from a Sirius editor. So when we have mathematical formulas, we can just enter them in a straightforward way, as you would expect from a text editor, and it would still work on the AST and not on the text level. So I think it's just just in quotations. The difference is in the flexibility of the notations that are coming out of the box with the projectional approach.
I think yes, but the key say KPI for that is the velocity of fulfilling the document, right? So why we are using text notation? Because it's much faster to do. Graphical is effective when you are using top to bottom. when you are just putting some boxes and just discussing the concept. When you need to add details, graphical is just that.
Yeah.
Right? And, and vice versa. Having text, you need to ever use excessive copy and paste or use some templates. But you are using kind of allowing to embed the editing from the final representation perspective, right? Exactly to the document. This is
Thank you. Other questions? Yes.
Is there any support for versioning?
Is there any support for versioning? What we support is, I like to claim it's infinite undo. So it's the model is stored in a way that you can completely roll back all the changes back and forth as you like, and you get a very detailed, so technically a very detailed diff representation. And on top of that, you can, of course, provide fancy diff merge visualizations. So yes, there's support for versioning, for branching, depending on the use case and the habits of people, like sending documents around, final 1, final 2, final beta something suffixes to 5 people via mail, and everyone is editing again, and then they try to merge again. So this kind of workflow becomes obsolete when you work on a versioned model that supports branching.
This is for business experts. They just need to define who is the most important.
Exactly, and merge conflicts are resolved by hierarchy. Yeah.
It's not version.
How
Yes.
is the performance compared with the ordinary parsing?
How is it with the performance compared to ordinary parsing? We don't have any concrete numbers yet with regards to what happens when I have models as big as, I don't know, the entire Eclipse code base. So I cannot answer that question, but the editing performance is pretty decent. So we are not at Vim or Emacs speed, of course, because we are also in a very early stage yet. But it's, I would say, okay-ish. So it's not getting in your way.
Do you support something like extraction of the fragment?
Maybe.
What do you think about formula-based editors to address this kind of problem as what approach?
Do you want to answer?
I can, yeah. So the question was, what do you think about formula editors for that approach? Is that the question? Okay, I think formula editors make sense because we did that for customers already, not with that technology, but with MPS. And they are really happy for having formula editors instead of coding or having other ways of notation. I mean, sometimes they just use Word because it has a formula editor. I mean, that isn't good, but at least it can have the notation that they want to have. And they are very happy when they have a more formal editor that has the very same support. And at the beginning, they don't feel comfortable because a formal editor with formulas is not as free as a normal formula editor in Word, because there is no button on the keyboard for a sigma sign. So you have to do something to define that. And what we normally do there is we have buttons at the right side so that you can see, as we have seen in the screenshot, there you see the formulas, the parts. You can click on that and then automatically the corresponding formula will get into the editor. So the answer is formula editors are very cool, but without having projectional editors so far, it doesn't work. And that is why people use Word or Excel. Does that answer the question? Thank you.
So we would have time for one more question. Okay, so
give it a try. We have a website. You can see what we think about the way Convecton works, and we have stories there from people telling why they need support for formal editors in the web. Maybe, yeah, just give it a try.
Yeah, So in fact, it's very early stage, but we are constantly adding content there. So you may not find too much technical information yet there. But still, if you have any more questions or something that pops up in your head, just approach us at our booth in like theater area. You will find us, and enjoy the rest of the conference. Thank you.
Thanks for listening.